Precalculus, it is the big day. It even says it's the big day. Here we go. We're going to find something called the exact value of the area between the x-axis and the curve of f of x is equal to negative 1/3 x squared plus 6. We're going to do that from x equals 0 to x equals 4. From x equals 0 right here to x equals 4, we're going to find that exact area. We start by using the area of 4 rectangles. Now we did this a couple of days ago, and so I'm cool with going back to the beginning and starting as if we hadn't done it. Just in case you forgot, the area of a rectangle is area equals length times width. So we will use that formula, length times width, in order to estimate this area. One important detail of this setup is the width of the rectangles will be on the x-axis. Okay, so each rectangle that we do will have a width here and the length will be up there. And all of the widths are going to be equal. We divide up the part of the x-axis that we're using into equal width rectangles. So if we're going to use 4 rectangles, the width of all 4 of them will be, this length is 4, so it'll be 4 divided by 4 rectangles. The width of each one of them will be 1. So I'm going to put a W in the side here, and then I'm going to put an L over here because the length is kind of the harder thing to deal with. The length of each rectangle will be determined by a Y value. That's going to be the height of a rectangle. In fact, it will be f of x sub I, where x sub I is the right endpoint. So we're going to use the right endpoint every time now. Last time we did this, we used the right and the left. We're just going to go with the right of the ith width. Okay, so what does that mean? When I equals 1, we'll be working with the first rectangle. When I equals 2, we'll work with the second rectangle. And when I equals 3, we'll work with the third. And when I equals 4, we'll work with the fourth. And we're going with the right side of each one of those rectangles. So our initial estimate for the area would be represented by f of 1 times 1. See, here's the first rectangle. I'm going to use the right side. I'm going to put 1 into the function. I'm going to go that high. I'm going to go that width times that length, and I will get this area of this rectangle right here. And the second one will be f of 2 times 1. The reason I have times 1 is because the width of the rectangle is 1. So I go 2 and I go up, and I go times 1. That gives me that area. And I will have f of 3 times 1. And so I'll take 3 and I'll go up until I hit the function, and I'll make a rectangle there, and I will go f of 4 times 1. And I'll go up just a little bitty. And there we go. And so this is my estimate for the area under the curve when I only use 4 rectangles. Well, let's actually find out what that is. F of 1, see, remember this right here, this is f of x is equal to negative 1/3 x squared plus 6. So what I got to do is actually put this value of 1 into that function to get this height. So that's going to go, I'll write it down here. I'll give you a little room. F of 1 is equal to negative 1/3 times 1 squared plus 6. That's just going to be 6 minus a third. That's 5 2/3. So this is really 5 2/3. I mean, it's times 1, I guess, so I guess I can put the times 1, but that's not really going to change value, is it? Then I got to find a f of 2 for this spot. Well, that's going to be negative 1/3 times 2 squared plus 6. Well, that's 4/3. It's 6 minus 4/3. That's equal to 4 2/3. So the second one is 4 2/3 times 1, which doesn't change the value. Okay, the next one, I have f of 3. Well, that would be negative 1/3 times 3 squared plus 6. So that's 9/3. That's negative 3. This value is just 3 times 1. And then the last one, I'm going to put in an f of 4. And when I put in f of 4, I get negative 1/3 times 4 squared plus 6. So that's 16/3. It's negative 16/3 plus 6. And so that ends up just being 2/3 plus 1. So I have, let's see, 9, 10 1/3, 10, 11, 12 1/3, 12 2/3, 12 3/3. I missed one. 9, 10, 11, oh, I missed one. It's 14 units squared. All right, that's my estimate using those 4 rectangles, and I think we all can agree that that estimate is too small. the exact value is going to be bigger than 14. Agreed? Good. Go to the next page. All right, kids. What if we used 10 rectangles? How would things change if I used 10 rectangles? Well, the width of each rectangle wouldn't be 1 anymore. It would be 4, the total width from 0 to 4, divided by 10. Each one would be 4/10 as a width. And we would have to find 10 different heights, multiply all of them times 4/10, and then add them up. But I don't want to write 10 area problems, so here's some more notation. If there are 10 rectangles, then I'm going to let I equal the number of the rectangle that we're sort of on. We start with the first one on the left, and then the second one, and the third one, all the way up to 10, right? So let's just write a little note here in case that throws you. That means I is going to equal 1 for the first interval, then 2 for the second interval, and then it'll go until I get to 10 for the 10th rectangle. So the x value of each right side of the rectangle is going to go like this. The first one, since the width is 410 and I start at 0, like imagine here's the 0, and we're going to 4, and we got this into 10 rectangles, right? Well, if they're all length 4/10, the first one will actually be the number 4/10. The x value for the first rectangle would be 4/10, and that's when I is equal to 1. Well, then the next one is another 4/10, so it's 8/10, right? But here's how I'm going to write it. I'm going to say it's 2 times 4/10 to get to that 8/10. That's when I is equal to 2. Then the third one, I would have 8/10, and then I would go 4 more, I would be at 12/10, right? But instead of just counting them like a recursive formula, I'm just going to do this like an nth formula. So it would be 3 times 4/10. It took me 3 4/10 to get over there. That's when I is equal to 3, until we finally get to the point where I have 10 times 4/10. That's when I would equal 10. And of course, that would actually be 4, which is where we're supposed to land, right? So our estimate will go like this. Area is approximately, it's going to be closer than the 14 that we got earlier, but it still wouldn't be quite right. The sum for I equals 1 to 10 of f of 4/10 I times 4/10, which is the width of the rectangle. Yeah, each width would be 4/10, so there's the width. Now how do I get the height? I got to put some x value in for x and get a y value. What am I going to put in? Well, the first one is 4/10, so when I put a 1 in, it's just 4/10. The second one, the right side of that interval, is 8/10. So how do I get there? I put a 2 in for I. 4 times 2 is 8/10. Then I put that in the function, and then 12/10 by putting in a 3, and then a 4, and then a 5. That is how this is going to work out. And the area of each rectangle is length times width. Well, there's your width, and there's your length after I put that into the function. You can see how our work yesterday is going to come into play here. Okay, if we use 20 rectangles instead of 10, this is how this would change. It is approximately I equals 1 to 20 of f of 4 divided by 20 times I. And it would be times 4 divided by 20. There's a pattern there, right? You see it? Now we're going to need to adjust the formula. One last adjustment before we really get to the real big deal here. We got to adjust this formula if we don't have x equals 0 as our left boundary. Like, it's real convenient to have that 0 there and go, well, since it's 4/10 wide, my first x value will actually be 4/10. But if I don't start at 0, if I start at like 6 and I'm going to 10, it's got to be like 6 plus 4/10. You see what I mean? 6 plus 4/10. So imagine finding the area from x equals 2 to x equals 4. That would start here at this 2 and end here at this 4, and so I would be finding this area right here. Well, you see what I mean? It doesn't make any sense to put in 4/10 in for x and get a y value, because that's nowhere near the area that I'm looking for. I would need 2 plus 4/10 to put that in and get my y value. Okay, the width would still be, it would be 4 minus 2. My width is 2 this time instead of 4, right? Divided by n, or it would be 2 over n. That's the width of my rectangle. That's for n rectangles, of course. But the right side of the width would now be x equals 2 plus 2nths times I. That's what I would be putting in. Start at 2 and then go to this distance of 2 divided by n rectangles. And you go times I. So when I is 1, you just go 1 interval over. When I is 2, you go 2 intervals over, and you go until you get to 4. With I equaling 1, 2, n. Okay, so at the bottom of this, before you turn the page, here we go. The area would be approximately the sum for I equals 1 to n of these two things times each other. F of 2 plus 2 over n I times 2 over n. Right? So those are the weird looking things, but when I put in like a 3 there, for the third interval, I will have 2 plus 6 over n. And that's what I'm going to put into the function, and away I go. You guys ready? Here we go. That big box is your formula. It's the first time you're going to see the whole thing. That's the formula for the area of any curve from any value a to b. Instead of 2 to 4 or 0 to 4, it'll be from a to b. And of course, the exact area, we wouldn't get it from 10 rectangles or 20 rectangles or even 100 rectangles. We'd be close with 100 rectangles, but it wouldn't be exact. It could be found by using so many rectangles that the width, in theory, disappears. Now, how do we do that? Of course, you take the limit as n approaches infinity. That's how many rectangles you have. I'm closing in on an infinite amount of rectangles, slamming them into that space. They got to be so skinny that they don't have any width. Here's the formula for the area between any function and the x-axis. From x equals a, pick any number you want on the x-axis, to x equals b, pick any other number. It goes like this. The area, I don't have to put approximately, it's exactly equal to the limit as n approaches infinity of the sum for I equals 1 to n, starting to look familiar, of, in a big bracket, f of a plus b minus a over n times I times b minus a over n, where of course that's the length and that's the width. You ready to do it? Here we go. Find the exact area for f of x is equal to negative 1/3 x squared plus 6. From x equals 0 to x equals 4. We tried this on the first page with 4 rectangles. We came up with an answer of 14, and we realized that was too small. Here we go. Well, if we're going from 0 to 4, I want to write underneath here, so a equals 0 and b equals 4. That's what we learned so far. We're going from 0 to 4, so I'm going to put a 4 there and a 0 there and a 4 there and a 0 there. All right, here it goes, kids. It's the limit as n approaches infinity of the sum for I equals 1 to n of, in brackets, f of 0 plus 4 minus 0 over n times I, and it'll be times 4 minus 0 over n. I'm starting out nice because I'm starting with x equals 0, where this 0 is going to go away and I don't have to substitute in a binomial expression. Okay, so this is equal to the limit as n approaches infinity of the sum for I equals 1 to n of a big bracket of f of 4i over n times 4 over n. Okay, so it doesn't look so scary now that I put an a and a b in there and simplified it a bit. Now what's my next step? 2 of them. I'm going to take this 4 over n and I'm going to put it right here because n is not a variable for the summation notation. Also, I'm going to put this into my function here. Negative 1/3 times 4i over n squared plus 6. So I'm going to do both of those in one step here. You ready? The area is equal to the limit as n approaches infinity of 4 over n, which I can bring out in front of this sum formula here. And it'll be times the sum for I equals 1 to n of this put in here. So here we go. negative 1/3 times 4I over n being squared plus 6. There we go. We have begun to find the exact value of the area under that parabola. It's a parabola that opens down, right? Okay, now I can break this into two different sum formulas. And so let's see if I can fit that in here. I'm going to write kind of small. That's the limit as n approaches infinity of, I've got 4 over n. Then I'm going to put a big bracket because I'm going to have two sum formulas. I'm really pushing it here. Sum formula number 1 goes 1 to n. Let's see. I got to square everything here, right? So I have a negative out in front. I have 16I squared in the top. And what do I have on the bottom? 3 times n squared. Okay, all I did was multiply all of that stuff together. 16I squared in the top and 3n squared in the bottom. And then what else do I have? I have the sum for I equals 1 to n of just a lonely old 6 out there. This one, I'm going to circle it because I can replace it right away. It's 6 times n. Okay, so I'll go to the next line and I have the limit as n approaches infinity of 4 over n times a big giant bracket. Now, what can I take out of here? The I squared right here, that's the only variable. So I can move in front of this sigma right here, I can move the negative 16 and the 3n squared. So I'm gonna negative 16 over 3n squared times the sum for I equals 1 to n of now it's just I squared. And then this one, it just became 6n. All right. Now I can replace this one, now that I have I squared by itself. And you guys look at your notes yesterday. Man, I don't know if I can put this on this line here. We'll try it. All right, so why did I write this so big? That was just dumb. Okay, little tiny equal sign. And then I'm going to go little tiny limit as n approaches infinity of 4 over n. And I got my big bracket. And so this is going to go negative 16 over 3n squared. And then I'm going to replace I squared with its sum formula. And we multiplied that out in class yesterday. It went like this. 2n to the third plus 3n squared plus n over 6. Okay? And then that's going to be plus just this 6n. The summation formulas are gone. Okay? No more sigmas, which make Liz happy, of course. Now, I do want to put this 4n over here, but it looks like I can put this together a little bit before I get into that. I don't have to get common denominators here. I can evaluate the limit of these two terms separately. So I'm going to hold off on the 4 over n for one more step here. I'll put that in last. I got a big giant bracket. Let's see, negative 16 times 2. That's negative 32 n to the third. Negative 16 times negative 3, that's minus 48 n squared, and negative 16 times plus n is minus 16n. On the bottom, I have 3n squared times 6, so 18n squared. Then after that, I still have plus 6n. Now it's going to be a lot easier to distribute this 4 over n, and it goes to both of them. There is a plus here still. So I got to go 4 times 32. That's 120 plus 8, so this will be the limit as n approaches infinity. There's no sigma anymore, right? So now I'm just going to have one bracket because I'm going to distribute this 4n to both of these, that being the second one right there. Negative 32 times 4 is negative 128 n to the third. Okay, 48 times 4 is negative 192 n squared. 4 times 16 is 64, I think, so that's minus 64n. And that's all going to go over this 18n squared, but there's another n coming in, so it'll be 18n to the third. And now I've still got a plus here, and I have 4 over n times 6n. That's going to be 24n in the top and an n in the bottom. Okay? We have gotten to the point. We have written this 1, 2, 3, 4, 5, 6, 7, 8 times. We have gotten to the point finally where we can evaluate the limit. For this first one, I have an n to the third at the top and an n to the third in the bottom. The rest of them don't even matter because they're smaller. And so I get negative, the area is equal to negative 128 over 18. Don't freak out about the fact that there's a negative there quite yet. And then it's going to be plus, well, this is the same as the top and the bottom also, so it's plus 24. So what happens here is that the 24 is bigger than 128 divided by 18. And so what I get out of the calculator is 16.8 repeating units squared. That actual area is 16.8 units squared. Let me go back. I'm using my notes over here, but let me go to this. From 1 to 4, we used 4 rectangles. We got an answer of 14. We decided it was too small. When you fill in the rest of these little things right here, by taking skinnier, skinnier, and skinnier rectangles, the limit as n approaches infinity, it actually turns into 16.8 repeating units squared. You just did some calculus. How about that? Let's go to the next page. Now look how scary that is. Look how scary that is. I think what I would like to do is I would like to do one of these and then hold off on the second one. I will start notes on Monday with that second one, but I'd like to do one more. And then maybe I'll do half of it and have you finish it off. Maybe we'll do that. And then Monday we'll start this, and then all we'll do on Monday, nothing new. We'll just do some area problems. All right? Use the limit process to find the area between the x-axis and the graph of, here we go, f of x equals negative x squared plus 3x. But look what I'm doing to you here. From x equals 1 to x equals 2. I'm not starting at 0. That's going to change the game a little bit here. So let's write off to the right so we don't screw anything up. So a equals 1 and b equals 2 when I go to start my formula. Let's remember that formula goes. Area is the limit as n approaches infinity of the sum for I equals 1 to n of two things. F of, let's see, I think it goes a plus b minus a over n times I. And then the width is b minus a over n. That's my formula. I've got a 1 and a 2. Let's find some area. So it's the limit as n approaches infinity of the sum for I equals 1 to n of, big bracket, let's write what we got to do here. F of, I put a 1 in here, it'll be 1 plus. When I go 2 minus 1, I get 1 over n times I. So I'm just going to write it like this. 1 times I over n. I think I said it wrong. Let me do that again. 2 minus 1 is 1 times I over n. 1 times I over n. Okay, and then this will be 2 minus 1, so it's just 1 over n. So the width is no big deal. Okay, we're going to do 2 steps in one here. I am going to remove this 1 over n because it is not a variable. I is the variable. I can't remove that. I have to actually put that in the function, but I can remove the 1 over n. And then I'm going to put this into that function and see what it looks like. You ready? Here we go. A equals the limit as n approaches infinity of the sum for I equals 1 to n. Dang it, I didn't take the 1 over n. All right, we'll do it on the next step. That's all right. I'm not erasing anything. I'm going to put all of this into that function. So it goes like this. Negative 1 plus I over n squared. That's by just putting this in for that x squared. And then I still have plus 3 times 1 plus I over n. And then that's all supposed to be times 1 over n. Okay. All right. Well, I'm going to do some multiplying over here. 1 plus I over n times 1 plus I over n. We actually did this in the notes yesterday for the same reason. Just do this off to the side. So 1 times 1 is 1. And then I have plus I over n. I have another plus I over n. And I have I squared over n squared. And these, of course, turn into 2I over n. There's 2 of them, so it's 2 times I over n. And that's how you can write that. So here we go on my third line. It's the limit as n approaches infinity. I'm going to remember to bring this over here this time because I'm not as stupid as I look. And then I'm going to have this, okay, maybe, I equals 1 to n, and a big bracket, and then I have a negative, and then all of this business right here has to go in parentheses with this negative. 1 plus 2I over n plus I squared over n squared. Then it's going to be plus 3 plus 3I over n. What I just did is distributed that 3 to those 2 spots. This I don't have to write because I moved it out in front. Okay, let's talk about this for a second. This is -1 minus 2i over n minus I squared over n squared. It's plus 3, and it's plus 3i over n. I've got some things that can combine. I've got a -1 and a 3. That's a 2. And I have minus 2i over n plus 3i over n. Those cancel a bit, and I get I over n. So here we go. It's the limit as n approaches infinity of 1 over n times the sum for I equals 1 to n of, I'm going to simplify this a little bit. Ready? -1 plus 3 is 2. -2i over n plus 3i over n is plus I over n. That's nice. That looks a little less complicated. And then I have minus I squared over n squared. I kind of feel like leaving you guys right there. This is what I think you should do, is finish this problem for homework. Hint, the next thing you're going to do is start the bracket here and do a sum of this, and then the sum of this. Once you write those, you'll take the n parts out. You'll substitute, then simplify, bring the 1 over n back in, and evaluate your limit. Let's see if you guys can get the right answer. Spoiler alert, it's 2 1/6 units squared. Do your work. You should get 2 1/6 units squared. All right, that's your homework for today. Have a good weekend. See you Monday.